Okay, for example 3, we have what is the domain of f of x equals negative 99 minus 4 sine of 47 theta minus pi over 900. Okay, now you might be thinking this is absolutely insane. If I go through the steps like I did before, this is going to be a ton of math. Well, I told you the steps are the same, right? So let's go ahead and do that. The steps were the same for example 1 for tangent. The steps were the same for example 2 for cosecant. Let's go ahead and start that process for example 3. Step 1, write the function in terms of sine and cosine. Well, it's already in terms of sine and cosine. Okay, there's no, it's already sine of whatever, regardless of how complicated this is. So what does that mean? That means that if I were to write this as a fraction, it would be 1 in the bottom. So I can plug anything into the bottom, right? Question is, can I plug anything into the top? Step 2, set the denominator not equal to 0 and solve for theta. There is no denominator, so I will go through the process of the algorithm. But basically, if I set the bottom not equal to 0, I say there's no denominator. Let's say it's 1. Okay, let's say 1 is not equal to 0. When is that true? That's always true, right? So that's giving us a hint as to what the domain is. Step 3, we're going to write it in generalized form. Because there's no denominator for sine and cosine, the domain for sine and cosine is theta is equal to all real numbers. I'm going to go ahead and circle that. Okay, that is true for all sine and cosine functions. The domain will always be all real numbers because there's no fractions, so there's nothing to plug into the bottom that could be a problem, right? There's nothing that I can plug into the bottom that would give me an undefined. Now, for step 4, for simplifying, you can just write it as theta is equal to all real numbers like that. Now, if we go back to the graphs of trig functions, there's secant, it has asymptotes, right? But if we go back to the graph of sine, we can see that it's going to go on forever like this. It's going to oscillate forever, and you can plug in anything, and get something back, right? It's going to oscillate like that forever, and because it's going to oscillate forever, the domain will be all real numbers no matter what. I don't know why my touch is messing up on me, but no matter what x value you plug in, you're going to get a y value back, and therefore that confirms our answer for theta is equal to all real numbers. So I kind of lied. The steps aren't exactly the same. We did go through the same step for step 1 and we did for step 2, but that was just to illustrate. Let's go back to the actual example. We did go through step 1. We wrote in terms of sine and cosine. We went through step 2 for just the same as the other examples. I changed up step 3 and 4 though because there's no inverse to take or anything like that. All we have to do is write in generalized form and simplify. So basically, what to take from this is the domain of sine and cosine is always all real numbers, regardless of how complicated this might look. It's basically there just to throw you off, but it's also there for comprehension's sake, for you to understand that anything you plug in, you're going to get a y value back. That's it for this particular example of the domain of a sine function or cosine function, all real numbers. If you have any other questions about this, let me know.